All right, so the beginning of Getting Ready 12 here, we're going back to, we worked on this in Unit 1 way back in September, October. We're going to multiply monomials together, which is really a way of saying we're going to work with our exponent laws. All right? So when we are multiplying powers that have the same base, like in number 1, all we do is add the exponents. So 2 plus 5 is 7, plus another 4 is 11. So this simplifies to x to the 11th. When we have coefficients in front of those monomials, we go ahead and just multiply those. Don't try to use any special rule. We just do 3 times negative 4 is negative 12. X, which really means x to the first, times x to the fourth, we're adding those exponents and calling that x to the fifth. And then this is y to the first times y to the third, that's y to the fourth. Again, multiply your coefficients first. Negative 4 times negative 2 is 8. A to the first times a to the fifth is a to the sixth. And then I have nothing to combine with this b to the third, so it just stays as is. Number 4 has an exponent outside of the parentheses. So our rule for that was, well, actually twofold. It went with everything inside. So it went with the 4, it went with the b squared, and it went with the y to the third. When there was already another exponent in there, we multiplied those exponents. So this became 4 to the third, b to the 3 times 2 is 6, and y to the 3 times 3 is 9. You could also, if you felt like it, go ahead and multiply 4 times 4 times 4 is 64, b to the 6th, y to the 9th. Okay, in this one, before you get excited and start multiplying negative 3 times 6, we're going to first have to apply this exponent that's outside the second parentheses. So the first one I'll leave alone for now, and that'll be multiplied by, now this is 6 to the second, which normally I would say you could go ahead and leave it 6 squared, but since I know I have a negative 3 out here to multiply with it later, I'm going to go ahead and say 6 squared is 36, and then x to the 2 times 3 is 6th power. Now I multiply negative 3 times 36 is negative 108. X to the, this is really the first, x to the first times x to the 6th is x 7th. And then I have nothing else but just the y squared. Okay, here, before I do anything with that negative 1/2, I need to apply the 2 exponent to everything in the parentheses. So that becomes m to the 2 times 3 is 6, 2 times 4 is 8. Now, I can't really change anything when I have that negative 1/2 times a couple of variables. All I can really do is say, oh, well, that's the coefficient of this term, so I can erase those parentheses and go, hey, it's just negative 1/2, m6th, and 8th. All right, now the newer stuff. We're going to multiply polynomials, specifically binomials. All right, so when we do a binomial times a binomial, the first way we ever talked about doing this was just straight distributive property, that you had to take each term in the first parentheses and it had to take a turn multiplying by each term in the second parentheses. And we do these so often, specifically binomials times binomials, that we had this little acronym, FOIL, that is so common. Even your parents probably used the same one. It even becomes a verb. Somebody can tell you, hey, FOIL this, and you'll know what that means. It stands for first, outer, inner, and last. And it's just a little acronym to remind you of which things have to get multiplied when you have two binomials. So first would be the first in one parentheses times the first in the other one. So x times x is x squared. Okay, that's the F in FOIL. Then outers would be x times negative 9. So the outers would give us negative 9x. The inners are the two inside. 5 times x would be positive 5x. And then the last is the last term in each parenthesis. So 5 times negative 9, the last gives us negative 45. Now, most of the ones that you will see in algebra class, the two middle terms, the x to the first terms, will be like terms. Not always, but often. So we do need to take that extra step and say this becomes x squared minus 4x minus 45. You can't stop at this middle step. We need this simplified trinomial. All right, first, 8x squared, outers, 28x, inners, negative 6x, last, negative 21. And like terms here in the middle, so 8x squared plus 22x minus 21. Now, this does not look like two binomials, but remember it's saying the entire parentheses, everything you see is squared. So this really should be rewritten as 5x minus 3 times another 5x minus 3. So first times first, 25x squared. Outers, negative 15x. Inners, another negative 15x. And last, negative times negative is positive 9. The two terms in the middle, now that's two of the same thing. That doesn't cancel. Negative 15 and negative 15 makes negative 30x. Right? They did not cancel and disappear. They combined to be negative 30. Right? Number 10, first times first, 10r squared. Outers, 35r. Inners, negative 6r. And last, negative 21. Combine the r terms, 10r squared plus 29r minus 21. First times first, 6x squared. Outers, 9x. Inners, negative 14x. Last, negative 21. Combine the like terms, we have 6x squared minus 5x minus 21. And we have another one where we're just presented with a binomial squared, so we'll write that twice as 4x plus 3 times another 4x plus 3, and then FOIL it. So 4x times 4x, 16x squared. Outers, 12x. Inners, also 12x. And last, plus 9. Combine our like terms for a total final answer of 16x squared plus 24x plus 9.